Okay, so solving exponential equations. In an exponential equations, variables occur as the exponents. So the power property of equality and the other properties of exponents can be used to solve exponential equations. What am I talking about? Well, the power property of equality says that if you have two bases set equal to each other, then their exponents have to be equal to each other. So in words, that says for any real number b, and b is not equal to 1, b to the x equals b to the y if and only if x equals y. In other words, two exponential expressions with the same base are equal if and only if their exponents are equal. Okay, so if I have 4 to the nth power equals 4 to the 1/2 power, then in this case, n would have to equal 4. If I have 5 to the x equals 5 to the third, then x has to equal 3. All right, so let's try a couple. If I have 6 to the x equals 216, notice a problem kind of is that the 216 is not as a base of 6. Okay, so what you can do is rewrite 216 as a power of 6 if you can do it. Now 216 happens to be 6 cubed. So this equation simplifies kind of to 6 to the x equals 6 cubed, and the power property of equality says that if I have two bases set equal to each other, same base, then the exponents have to be equal to each other, and x equals 3. So I can check that by putting in 3 for x in the original equation. If I have 6 cubed, I get 216. So x equals 3. That's my answer. In this one, I have 25 to the power of x minus 1 equals 5. Now that's 25 to the x minus 1 power, not 25 to the x minus 1. It's not that. The x minus 1 is the whole entire exponent, and you're allowed to do that in exponents. Okay, but notice the bases aren't the same. This side has 25 as the base, this side has 5. But I can rewrite 25 as a base of 5 as 5 squared. Okay, so 5 squared to the x minus 1. All I did was rewrite 25 as a power of 5. Now, be careful here. I have 5 squared to the x minus 1 power. So I have power to a power, which says I can multiply those exponents. So I would have to actually distribute the 2 to the x minus 1 in the exponent. So it becomes 5 to the 2x minus 2 equals 5 to the 1. Well, the power property of equality says that if I have two bases set equal to each other that are to the same base, then I can set the exponents equal to each other. So I just have 2x minus 2 equals 1. Then solve for x. Add 2, divide by 3, and you get x equals 3/2. Then you could check that. If I have 3/2 in for x in the exponent, we'll do 3/2 minus 1, which is 1/2, and 25 to the 1/2 power is equal to the square root of 25, which equals 5. Okay, show that extra step there. Alrighty? Alright, here's a couple for you to try. Go ahead and pause the video. Okay, we're back. So the first one, 5 to the x equals 5 to the third, because 125 is 5 cubed, so that means x equals 3. And if I check it, 5 cubed equals 125, and it does. Okay, this next one, 12 to the 2x plus 3 equals 144. 144 is 12 squared. So now I have the same bases. I can set the exponents equal. So 2x plus 3 equals 2, and solve for x. So subtract 3, I get 2x equals -1. Divide by 2, so x equals -1/2. Now if I check that, I get 12 to the 2 times -1/2 plus 3 equals 144. All right, 2 times -1/2 is -1 plus 3 would be 12 squared, and that equals 144. So we're good. Pretty cool stuff, huh? All right, so remember at the beginning of the lesson, we said that to find the SPF that absorbs 100, we talked about the SPF formula. I want to find the SPF that absorbs 100% of UVB rays. So remember, the equation was P equals 50 times F to the 0.2 power, which I know is not a fraction, but 0.2 is the same as 1/5. So we're going to rewrite it as a 1/5 exponent in a minute. So remember, P stood for the percent, so I substitute 100 in for P, okay? Then I can divide both sides by 50, so I get 2 equals F to the 0.2. Then I can rewrite 0.2 as a 1/5 power. That's just because the decimal 0.2 is 2/10, and 2/10 is the fraction 1/5, right? 2/10 is equal to 1/5 if you reduce it. That's all I did in that step, was just rewrite 0.2, the decimal, as a fraction. Okay? Now, since 2 is understood to have an exponent of 1 on it, I can rewrite that as a 1/5 power by saying, well, 2 to the 5th power to the 1/5 power. That's the same as 1, right? Because 5 times 1/5 is 5/5, which is 1. The reason I did that was so that I get each side raised to the 1/5 power. Okay? So 2 to the 5th has to equal F. So F equals 32. All right? Cool. All right, here's one for you to try. Go ahead and pause the video. All right, we're back. So the radius of the nucleus of an atom of mass number A is R equals 1.2 A to the 1/3 femtometers. Find A if R equals 3.6 femtometers. Okay, so you don't really need to know all the chemistry involved, just know the equation and what you have to put in where. Well, they say R equals 3.6, so you'd have 3.6 equals 1.2 A to the 1/3 power. You can divide the 1.2 off both sides. So you get 3 equals A to the 1/3. Okay. Well, since it's 1/3 power, I want to rewrite this side with a 1/3 power. But if I just q 1/3 this side, I will change the equation. So what I have to do is write it as 3 to the 3rd to the 1/3 power equals A to the 1/3 power. Okay? So 3 cubed has to equal A, so A equals 27. And that's our answer. All right, guys, that's it for this section. Please continue on to your assignment, and as always, reach out to me if you have any questions. Take care.